Hello everyone, welcome to this video. So you all know about Pythagoras' infamous theorem about right angle triangle, right? So the theorem says that if we have a right angle triangle with its hypotenuse being C and the other two sides being A and B, then we have this relationship between the sides. A square plus B square is equal to C square, right? That means if we draw a square on this side on A and then we draw another square on B, then and we draw another square on C, then the area of these two square area of the two square that we will draw on over A and B will be, if we combine them, that area will be equal to the area of the other square that we will draw over the hypotenuse. And it's probably one of the most famous theorem in geometry, and I think it's one of the most famous theorem in mathematics in general. And there are hundreds of proofs out there, but in my humble opinion, the proof that I'm going to show you right now is probably the one of the simpler proof out there. All right, so let me take you through the proof. Okay, so we have these four different copies of same triangle, same right angle triangle with its two of the other sides being A and B and hypotenuse being C, and this is the 90 degree like right angle. So basically these are the four different copy rotating different angles. So this one is rotating 90 degree, like I rotated 90 degree and I got this one. I rotated this angle also 90 degree, I got this one, and then also another rotation, I got this one. So basically they are the same triangle, all of its sides being A, B and C, right? And so what is the area of this triangle, each of this triangle? Well, we know that the area is of a triangle is half multiplied by the base multiplied by the height. So what is the area of this triangle? Well, let me right click A, and the height here is A and the base is B, or you can say the base is A, height is B, depending on the point of view. The area is half AB of each of the triangles. Okay, now what I did there, I did something clever. I just combined all of the four triangles here. So basically let me just number this triangle. This is number 1 triangle, this is number 2, number 3 and number 4, and I put them together. So I just put number 1 triangle here, second triangle here, third triangle here, and fourth triangle here in a way so that it made a new quadrilateral. Actually they made two quadrilaterals. So there is a bigger quadrilateral, as you can see, this is a big quadrilateral, and there is a smaller quadrilateral inside, shaded quadrilateral. Okay, so the question is, what can we say about this two quadrilateral? Well, this quadrilateral, all of it, this side is C. So because this is, let's say this is the triangle, and this is, let's say, A. This side is A, the length of this side, and the length of this side is B. That means this has to be C. Already claimed it here. We already assumed it to be C. So all of its sides are C. We know this. So can we claim that this is a square? This bigger quadrilateral is a square? We cannot, because it could be a rhombus, right? We don't know anything about the angle of this quadrilateral, but it's not very difficult to prove that all of its angles are actually 90 degree. Well, how do you prove it? Well, I will leave it as an exercise to you. Try to prove that why all of its angles are 90 degree. Actually, it's not a very difficult exercise. You will need two things. I'll give you a hint. So you will need to know the fact that the summation of the interior angles of a triangle is 180 degree. So basically the interior angles of a triangle adds up to 180 degree, right? So this is the theorem. So let's see if we have a triangle here, A, B and C. We have these three angles. They adds up to 180 degree, right? So this is the basic theorem from high school geometry. So you will just need this theorem and the fact that all the triangles are congruent triangle to prove that this all the four angles of this quadrilateral is 90 degree. Well, if we know this, that all the four angles of this quadrilateral is 90 degree and all the sides are also equal, which is equals to C, that means this is a square. So we have this big square with an area of what? Area is C square, right? Now, what about the smaller square? Well, the smaller square, all the four angles of the smaller square is smaller square. I was talking about the smaller quadrilateral. We still don't know whether it's square or not. This is a smaller quadrilateral, a smaller shaded quadrilateral. So all the four angles are actually 90 degree. It's not very difficult to show because we assumed all the triangles to be 90 degree, and let's say this one is 90 degree, and as this whole angle is 180 degree, this also has to be 90 degree. So this angle is 90 degree, this angle 90 degree. Similarly, all the four angles are 90 degree. So we know that we have this smaller quadrilateral with all of its angle being 90 degree, but we don't know anything about the sides. But again, it's not very difficult to show that all of its sides is equal to b minus a. How can we show this? Well, this part of this side of this triangle is equals to b. Actually, this is b because we assume this longer side of the right angle triangle is b. So this side is b, and this side, which is the smaller side of the angle, is a. So we're gonna get the side length of the side of the smaller quadrilateral. If we subtract b from a, we're gonna get this side, which is equal to b minus a. Similar way, we can show all the four sides are equal to b minus a. So we have this smaller quadrilateral with all of its angle being 90 degree and all of its four sides being equal to b minus a. That means it's also a square. So we have this smaller square, we have also a bigger square. And what is the area of the smaller square? Well, as all of its sides are b minus a, area has to be b minus a whole square. Now we'll make a very simple observation. The observation is that if we combine the area of this small square with the area of all the four triangles, we're going to get this bigger square, right? So you're going to write an equation form. So what will be the equation? So what is the area of the bigger square, which is c square? You already wrote it here. So c square is equal to what? C square is equal to the area of the smaller square, shaded square, and the area of all the four triangles. So the area of the smaller square you already saw is b minus a, right? B minus a whole square, right? Plus, we already showed that we already know actually the area of each of the triangle is half AB, and we have four triangles here, so the combined area is 4 multiplied by half AB. Now if we calculate it we'll have b square minus 2ab plus a square, right, from the high school formula that we all know, and we'll have 2ab here. This 2ab and this 2ab will be cancelled out, and we'll have c square is equal to b square plus a square. And if we just rearrange it, we can write this part here, a square plus b square is equal to c square, where a and b are the two sides of the two adjacent side of the right angle, and c is the hypotenuse. So we have this relationship a square plus b square is equal to c square, which is exactly what Pythagoras' infamous theorem claims. So we are done. Simple, isn't it?